some basic probability, right? Basic. There's tricky probability, like there's tricky counting arguments. We're not doing tricky probability. We're just doing basic probability, right? And so I'm going to do a few examples, right? So the first thing we're going to do is we're going to flip a coin, right? And I'm interested in what is my probability of getting tails, all right? So, and actually before you give me an answer, I need to make sure you understand what probability is. So, okay, what is probability? Probability is a number between 0 and 1. All right? Probability of 1 means it's definitely happening. Probability of 0 means it's definitely not happening, right? And anything in between is kind of a range, right? Like if I were going to say the probability of rain today is 100%, what would you think? Guess what? It's raining, right? So, if I said a probability of rain is 1, like we're not going to use a percent, right? So, what is your probability, if you're flipping a coin, a fair coin, anytime so I'll talk about a fair coin. What is your probability of getting a tail? 0.5, right? 1/2 or 0.5, okay? And actually, let's talk about, well, what's the probability if I roll a die, right? So I'm talking regular 6-sided die, right? What is my probability of getting a 2? Say it. 1/6. Does that make sense? So think about a die, right? 6-sided die. What's your probability of getting exactly a 2? Well, your probability of getting exactly a 2, well, there's only one way to get a 2 and there's 6 sides, and so it's 1/6. Right? And then if I talk about days of the week, right, what is my probability of getting a weekend?
2 out of 7.
Are we okay? 2 out of 7? Right, because there's 7 days and it's 2 out of 7. All right, so I probably should have. Here, I'm going to color code this. So probability of getting a tail is a 0.5. Probability of getting a 2 on a die is 1/6. The probability of getting a weekend is 2/7. So far, so good. Well, we're also going to need the probabilities of not getting what we want, right? So I want to talk about not a tail. I know that's a head, but you'll see why I call it not a tail, all right? Not tails, all right? Not a 2. And not a weekend. Right? So, what's my probability of not getting a tails? 0.5, right? What's my probability of not getting a 2? 5/6, right? What's my probability of not being on a weekend? 5/7. Is everybody okay with this? All right. So, the idea is, right, the probability of something happening plus the probability of it not happening better add up to 1. See how this plus this adds up to 1, this plus this adds up to 1, this plus this adds up to 1. Are we okay? All right, so that's my intro probability, right? Now we're going to use this to answer some questions. So the first question I'm going to talk about is, I'm going to flip a coin 4 times. All right? And so I'm going to flip a coin 4 times, and I want exactly 2 tails. And don't write what I'm about to do now. Right now I'm going to draw a picture. Okay, so everybody understand the situation? I'm going to flip a coin 4 times, and I want to know exactly how many ways I can get exactly 2 tails. And so I'm going to write them all out. If I'm going to get exactly 2 tails, I could either get the 2 tails at the beginning and then the 2 heads at the end, right? Or I could have 2 heads at the beginning, I can get the 2 tails at the end, or I could do tails, heads, tails, heads. I could do heads, tails, heads, tails. I could do heads, tails, tails, heads, or tails, heads, heads, tails. Do you see these are all the possible ways I could get exactly 2 heads? Right? How many ways is that? Is everybody okay? There's 6 total ways? Well, okay, that's fine, right? If I'm only flipping a coin 4 times, I want to know exactly how many ways I get 2 tails. I could write them out and I get 6. But what if I flip a coin 14 times, right? And I want to know exactly how many ways I can get 2 tails. Do you see I'm going to have to write down a whole lot more choices? And then how do you know if you got them right? Or if you've got all of them? So we need a better way to count how many ways. And the good news is we have a better way to count. Because here's what we have. How many positions do we have? 4. How many of those positions do we want to be tails? 2. And so another way of looking at this, because I don't need this actual presentation, I just need to know how many of them are, is I could look at this and say, oh, this is going to be 4 positions. I want 2 of them to be tails. And guess what 4 choose 2 is? 6. Right. Did everybody see how I got that? Right? So what this does is, so 4 choose 2, this represents the number of ways to get exactly 2 tails. Or 2 of whatever I wanted. Like I wanted 2 tails, so that's it, right? All right, now, what I'd like to know is, what's the probability of exactly 2 tails, right? So this tells me how many ways I can get 2 tails. I want to know what's my probability of getting exactly 2 tails, right? And here's how it works. And I am going to preface this, that this first example, this is the easy example, but sometimes easy examples are harder to understand. It's easier to understand a harder example. So we're going to go through this situation. We've got this sort of setup. We're going to go through a couple of questions, and then we're going to go through one that's seems like it's harder, but I think it'll make it a little clearer. Right? All right, so here's how you compute an actual probability. First, you have to count how many ways this can happen. And then you have to compute the probability. Now, here's how it works. We're going to multiply by 2 numbers. Okay? First of all, what is the probability of getting a tail? 0.5. All right? So I'm going to sort of label what we have here. So this is the probability of tails. And this is going to be the probability of not tails. I know I could say heads, but my life is going to be easier if I just do this. So the probability of getting a tails is 0.5. What's your probability of not getting a tails? 0.5, all right? And how many tails do we want? 2. Right? So you won twice, right? Because this represents winning, getting what we want, right? We want tails. How many ways did we lose? Twice. Right? So let's sort of recap. There's 3 things that we've got to do. First, we have to count the number of ways I can get what I'm looking for. And so what I'm looking for is exactly 2 tails. Then I need the probability of, if you're flipping a coin 4 times, you're going to get tail. If I want to know how many ways I can get tails. So there's 2 ways I'm going to get tails, and there's 2 ways I'm not going to get tails, which is why there's a 2 and a 2, right? And now our job is to, I want to compute this number. All right, so everybody get a calculator out. If you need to borrow one, come up and get one. But I want to compute what this number is. So 4 choose 2, well, we already know that's a 6. That's going to give me 0.25. It's going to be 0.25. What did you get? 37.5%. Don't want a percent, I want a probability. Yeah. So 0.375. All right, and I'm going to make up a little chart.
Wait, Mr. August.
Yes.
How'd you get the 2 for the exponent? I still don't get it.
This 2?
Mm-hmm.
All right. I wanted 2 tails.
Okay.
Right? The next example will make a little more sense.
Okay.
All right? All right. So if I'm making up a chart, this is how many ways I get exactly 2 tails. Okay? Well, what if I want exactly 1 tail? All right? If I want exactly 1 tail, well, I want to find out how many ways that can happen, which means I've got 4 position. I want one of them to be a tail. Okay? And then I have this probability stuff. Okay, this is the probability. What's my probability of getting a tail? 0.5. What's my probability of not getting a tail? 0.5. How many tails do I want? If one of them's a tail, that means 3 of them are not going to be tails. So everybody practice typing this in, and what do we get? You get 0.25? That's what we got first period. Now let's think about this. Right? Let's look at these probabilities. Does it make sense that if you're flipping a coin 4 times, you're more likely to get 2 heads than you are 1? Think about it, you're flipping a coin 4 times, right? And it's a coin, so you should expect that you should get about half of them heads. Right? So this is more, right? All right, well, what if I want 0 tails? Let's find out what that is. So if I want 0 tails, well, so that's going to be 4 spots. I want to choose none of them to be tails. This is the probability of getting a tail, so that's going to be 0.5. I don't want any of those, which means I'm going to have 4 things that are not tails. And I think if you multiply that out, that's going to give you 0.0625.
Yeah.
Okay. All right, so now let's just sort of look at the numbers. Let's see how these numbers work. To get exactly 2 tails, that's got a probability of 0.375. To only get 1 tail, it's got a probability of 0.25. Probability of getting no tails is 0.0625. Now, that means you got all heads, right? It's possible you get all heads, but it's rare. Okay? So there's 2 types of questions I can ask. The first question is, all right? So the easier question is, find the probability of exactly 2 tails from 4 coin flips. Okay. So I say find the probability of exactly 2 tails from 4 coin flips. And what's the answer to that question?
0.375.
0.375, right? Does everybody see that? Of course, if I changed it, well, what's exactly 1 tail, exactly 0 tails, and we have those other numbers, right? Question.
Why is it exactly 2 tails? Or is that just...
Okay. So here's version 2 of the question, right? Version 2 of the question is probability of at most 2 tails. You see the difference? Now let's make sure we understand the difference between exactly and at most. If I say exactly 2 tails and I flip it 4 times, right? What do we need to win? I need 2 tails, right? Did everybody understand that? I mean, the wording is, if I say, I'm going to call it to win, all right? To get the desired result, all right, is to win, all right? I want exactly 2 tails, right? To get exactly 2 tails, we computed it, we got 375. Now let's think about at most 2 tails. All right, let's see what that means, to win, right? What does it mean to win, right? Right? So at most 2 tails. If I get 1 tail, do I win? Yeah, right? Do you see that getting just 1 tail wins? Because I'm still following at most, right? If I get no tails, do I win? If I get 2 tails, do I win? Do you see that it's easier to win at most as opposed to exactly?
Yeah.
Right? Does everybody understand that part? I say to win. I'm speaking like my 3-year-old. He says, I want to win. Right? Right? To get the desired result of, so at most 2 tails. All right? So how do we find out what's the probability of at most 2 tails? Well, at most 2 tails is you've got to add up all the probabilities that win. Meaning, and this is the shorthand, we have to add up the probability of exactly 2 plus the probability of getting 1 tail plus the probability of getting no tails. Okay? And if I do this, if I add all this up, then that tells me my probability of at most. So somebody add all those up, what do we get?
.6875.
0.6875. Okay, here's what that tells me. Just to make sure we understand. If I flip a coin 4 times, right? I mean, that's 2/3 chances of getting at most 2. Now, if I get more than 2, well, then that's a problem, right? Then I lose. Okay, so I'm going to recap this. I promise this will make more sense with the next example. I'm just kind of setting all the parts up. See, here's the part. To compute a probability, the reason this is called a binomial distribution is we're doing something that has 2 outcomes. When you flip a coin, you have 2 outcomes, heads or tails. All right? So everything we're going to do today has 2 outcomes. And you need 3 things. First, you need to count how many ways it can happen. And then you have to multiply it by the probabilities. It's the probabilities of it happening times the probability of it not happening. Because if you have two way, if this is in this case you're getting heads twice and not heads twice, so I'm counting up the probabilities of the heads and the probabilities of the not heads. All right, so let's look at another example. So here's the situation. We're going to say that somebody is a 70% free throw shooter. Okay? So 70%, okay. So you're a 70% free throw shooter. And so what I'm going to do, right, is we're going to talk about his, if he's a 70% free throw shooter, what is his probability of making his shot? Remember, probabilities is
7, 10 shoot 7. Wait, no, I mean 0.7. Oh my god.
okay. Probability's got to be a number between 0 and 1. So if you're a 70% free throw shooter, what is my probability of making 1 shot? Are we okay? That's 0.7. So my probability of making it is 0.7, right? What is my probability of missing? Are we okay with this? Does everybody understand the situation, right? So you have a 0.7, right, probability of it working, and you have 0.3 of probability of it not working. So every one of these problems, you have to determine what is your probability of success and your probability of failure. Yes.
Why are they not percentages?
Probabilities are because probabilities have to be a number between 0 and 1. You can convert them, all right? There is a conversion, right? But to do the math, it needs to be a number between 0 and 1. Right? Right. So now here's the question. All right. So level 1 question is, so we're gonna take 5 free throws. We're gonna take 5 throws. Okay? I want to know what is the probability, okay, of, I'm going to say, I want to know what's my probability of exactly 3. And I don't mean to draw a line here. In fact, you could erase this. I'm leaving it up here because I kind of need it for reference. If I could, I would have shifted it all the way over here. All right, so I want to know the probability of making exactly, I want to make exactly 3 free throws. All right, so here's how we do that. First, we want to count the ways we can make exactly 3. How many shots are we taking? 5. How many of them do we want to be? How many of them do we want to work? 3. Are we okay? So this is going to be 5. Choose 3. We're counting the number of ways we can make. So we're counting the number of ways we can make 3 free throws. Tongue twister. All right. What is your probability of success? 0.7. 0.7. And how many of those? How many times did we succeed? 3. What is your probability of failure? 0.3. And how many of those? How many times did we fail? 2. Does everybody see that? Well, can you compute it? So everybody type it in your calculator and compute this. Yeah. 0.3087. Okay. Is it making a little more sense where the numbers go? I think it's hard to see what to do when the probabilities of success and failure are the same. I think it's easier to see when the probabilities are different. All right, so are we okay? This is exactly 3? Okay, so now I want to know what's my probability of making exactly 2? What would that look like? Oh, that's going to be 5. Choose 2. Right? Because we're taking 5 shots, we want 2 of them, right? So I've got my probability of success and my probability of failure. How many times did we succeed? 2. How many times did we fail? 3. And what number is that? 0.1323. What's my probability of making exactly 1? Is everybody okay with it? So if I'm setting this up, the probability of making exactly 1 is going to be 5, choose 1. And then I'll have, I only made 1. That meant I missed 4. What number do we get? .02835 sounds good to me. And what is my probability, if I am a 70% free throw shooter, what is my probability of making none? What does that look like? So that's 5, choose 0. I don't make any, and I miss everything. I think that gives me 0.00243. If you think about it, does it make sense that if you're a 70% free throw shooter, it would be very rare for you to miss 5? Right? I mean, if you just look at these percentages, I mean, not percentages, but if you look at these probabilities, notice you're more likely to make 3 than you are anything else. All right? So everybody understand this? So If I give you 5 throws, if I say what's the probability of making of exactly 3, what if you're still a 70% free throw shooter? I ask, find the probability of making at most 3 free throws. And so what would we need to do to find the probabilities of making at most 3? Yeah, add them all up. I need to know what's my probability of making 3, plus my probability of making 2, plus my probability of making 1, plus my probability of making 0.
Point 47178.
Point what?
47178.
Point 47178.
That fixed.
Yeah, that looks right. Okay. Does this make a little more sense? Okay. Now, there are tricky versions of this problem. I'm not going to give you tricky versions of it today or on the quiz, right? But the main idea, and so here's kind of the official. If you look up probability distribution anywhere, they're going to give you this formula. I'm going to put the formula that they typically put in. The formula they typically put in is they'll say, given n tries, either you flip a coin n times or you shoot the ball n times or whatever, they'll say it's n choose k, and then they call p as the probability of success, and that's going to be to the k, and then it's going to be 1 minus p to the n minus k. And I didn't give you that formula at the very beginning because that formula looks incredibly intimidating. But let's look at that. Do you see that n represents how many shots we're taking? K represents what we want. Probability of success, and then how you got the 0.3 is you did 1 minus that. And then you have to make sure these two things add up to n. So, after doing a few problems, you can see, okay, this is where they came up with that formula, but I would never give you that formula at the beginning because I think that just confuses things. All right.